Good day to all. Today we are going to discuss about electrochemical principles of metallurgy. In the first unit, metallurgy unit. Okay. In this, similar to thermodynamic principles, electrochemical principles also find out the applications in metallurgical processes. Adiliyum metallurgical process find பண்ணுவோம், இதுலயும் அதான் பண்றோம். சரியா? And then more active metals of oxides like sodium metals, active metals like sodium, potassium, etc. Like these metals, this metal oxide cannot be reduced by using carbon. Carbon வச்சு reduce பண்ண முடியாது by using carbon. So like these metal oxides can be reduced by using suitable reducing agent by using electrochemical principles. Okay, so thermodynamic principles la indha mari metals reduce panna mudiyadhu. So we can reduce this like this compounds by using electrochemical principles. Okay, now the metal salts are taken in a fused form. In this process, in this technique, metal salts are taken as a fused form or solution form. Metal salts are taken as a fused form or solution form. Okay, fused form or solution form. So in this, metal ions can be reduced by using suitable reducing agent or electrolysis. Okay, metal ions can be reduced by using suitable reducing agent or electrolysis. Reducing agent or electrolysis. Okay, so reducing agent vachi reduce pannalam illa suitable electrolysis process vachi reduce pannalam. Okay, so metal salts eppadi edukanum, fused form la edukanum or solution form, and then metal ions can be reduced by using reducing agent or electrolysis. Okay, gives free energy for the reaction. After the reaction, gives free energy for the electrolysis process means delta G naught equal to minus NF E naught. Delta G naught equal to minus NF E naught. Here N is the number of electrons involved in the reduction process, and then F is a Faraday, E naught is the electrode potential of the redox couple. Okay, so N is a number of electrons involved in the reduction process. F is a Faraday and and E naught is electrode potential of the coupled reaction. Electrode potential of the coupled reaction. Potential of the coupled reaction. If E naught is positive, means delta G naught value is negative. Okay, delta G naught value is negative, and then EMF of the solution or EMF of the electrolytic process is positive. EMF of the electromotive force of the electrolysis process is positive. Okay, so E naught is negative means positive means delta G naught value is negative and EMF value is positive. Okay, and then the reaction pathina more reactive metal is added to the solution. First of all, more reactive metals added to the solution. More reactive metal added to the solution. Okay, this solution contain relatively less reactive metal ions. This solution so more reactive metals solution add பண்றோம் இல்லையா, இந்த சொல்யூஷன்ல என்ன இருக்குன்னா less reactive metals. Less reactive metals, relatively less. இதை கம்பேர் பண்ணுற more reactive metals கம்பேர் பண்ணும்போது the less reactive metals இருக்கும். Okay, and then the more reactive metals go to the solution. More reactive metals go to the solution. Okay, for example, copper is added to the silver ion to form copper 2 plus and 2Ag is formed. More reactive metals, copper added to the less reactive metals ஆன silver add பண்றோம் இல்லையா, and then copper get ionized, oxidized to form, and then we get silver metal reduced. Okay, so Cu 2Ag plus to give Cu plus and Ag, and then Cu2 plus is added to the zinc metal to form copper and Zn2 plus. Cu2 plus is added to the zinc to form copper and zinc 2 plus. Yeah, okay, it's a solid. This is aqueous solution. This is a aqueous solution. This is a solid one. This is aqueous solution. This is a solid. This is solid. This is a aqueous solution. Okay, aqueous solutions. So more reactive metals added to the solution to form less reactive metals get reduced, and metals பாத்தீங்கன்னா more reactive metals நமக்கு clear reduction ஆகி கிடைச்சிரும். less reactive metals reduction ஆயிடும், more reactive metals solutionல போயிட்டு add ஆயிடும். Okay, this is the reaction of electrochemical principles of metallurgy. Okay, and the next topic is next one, electrochemical extraction of aluminum. Electrochemical extraction. Electrochemical extraction of aluminum. By using Hall-Heroult process. Hall-Heroult process. Hall-Heroult process. Okay, so extraction of electrochemical extraction of aluminum by using Hall-Heroult process. So in this process, Hall-Heroult process, in this process, the electrolysis process carried out in iron tank. In this process, எதில் ப்ரொசீட் பண்ணுறாங்க, iron tankல ப்ரொசீட் பண்ணுறாங்க. So iron tank. This process carried out in iron tank. This iron tank is linked with carbon. This iron tank linked with carbon. This carbon act as a cathode. Act as a cathode. And also carbon blocks emerge in a electrolysis solution. Okay, carbon blocks are immersed in a electrolytic solution. This carbon blocks act as a anode. This carbon blocks act as a anode. Okay, now 20% of alumina. 20% of alumina is mixed with molten cryolite. Molten cryolite. Molten cryolite add பண்றோம். Okay, and then 10% of calcium chloride. 10% of calcium chloride. The next one, electrochemical extraction of aluminium by using Hall-Heroult process. Okay, so in this process, electrolysis process carried out in iron tank. Iron tank will proceed பண்ண போறோம். Okay, the iron tank is linked with carbon. This carbon act as a cathode. And then carbon blocks are immersed in electrolyte. That carbon blocks act as a anode. Carbon blocks immersed in a electrolyte. This carbon blocks act as a anode. Now 20% of alumina. 20% of alumina is mixed with molten cryolite. Molten cryolite and also added with calcium chloride. 10% calcium chloride. of calcium chloride. These mixtures, that is 20% alumina, molten cryolite and 10% of calcium chloride is maintained at the temperature of 1270 Kelvin. Maintained at the temperature above 1270 Kelvin. Okay, 1270 Kelvin temperature maintain பண்ணணும். Okay, now the reaction is carried out. This calcium chloride எடுக்கணும் இல்லையா, the calcium chloride helps to lowers the melting point of the metal. என்ன செய்யும் add பண்ணா lower the melting point of the metal mixture. Okay, the mixture உடைய melting points lower பண்ணும். Okay, and then aluminium எடுத்துருக்கோம் இல்லையா, aluminium obtained from bauxite ore. The 20% aluminium is obtained from bauxite ore. So 20% alumina, molten cryolite and 10% of calcium chloride. This mixture is maintained at the temperature of 1270 Kelvin. Okay, this aluminium is getting from or obtained from bauxite ore. 10% of calcium chloride is to help the lower the melting point of this mixture. Okay, now the electrolysis. Now the electrolysis is proceeded in the mixture. Proceed ஆகும் இல்லையா. Now the ionization of alumina, that is Al2O3 ionized ஆகுது இல்லையா. So Al3 plus O2 minus. Here 2 aluminium. So 3 oxygen. Here 3 oxygen. Okay, and then reaction at cathode. Reaction at cathode. Al2 Al3 plus plus 6 electron, 2 electrons எடுக்கிறோம் இல்லையா, Al2O3. So 6 electron is consumed to form aluminum metal, pure aluminum metal. And then reaction at anode. Reaction at anode is oxygen, okay? 6O2 2 minus 6O2 minus 2 gives electrons. என்ன கிடைக்கும் உங்களுக்கு? Oxygen form ஆகும். So oxygen form ஆகும் இல்லையா? And 12 electron is expelled. Oxygen and 12 electrons is வெளியில போகுது. So O2 minus to form O2 plus 12 electrons. This is the ionization reaction. It's a reaction at cathode, the reaction at anode processes. Okay, and then carbon act as a carbon blocks add பண்றோம் இல்ல, carbon act as a anode. Since the carbon act as a anode, carbon get oxidized to form CO 2 minus to form CO. Okay, and 2 electrons leave out. And then carbon plus 2O2 minus to form CO2 plus 4 electrons will go. 4 electrons go. சரியா? And then the net reaction of the electrolysis process is Al3 plus என்ன இருக்கு அப்புறம் oxygen இருக்கு 6O2 minus 4 and then carbon 3 carbon to use aluminum 4 aluminum கிடைக்கும் and then carbon dioxide 3 carbon dioxide is formed. This carbon dioxide is a gas, is a liquid. Aluminum is a liquid. This is the net reaction of extraction of aluminum process. Net electrolysis process of the net reaction is that. And then we get pure metal. We get pure aluminum is formed at the cathode and settled down at the bottom. Aluminum settled down at the bottom. Okay, this is the electrochemical extraction of aluminum Mat.Hr.Sec. process. Okay, so the ion tank. This process proceeded in ion tank. Carbon is linked with the ion tank. So carbon acts as a cathode and carbon blocks immersed in the electrolyte solutions. Carbon blocks act as a anode. Okay, and then 20% of alumina, molten cryolite and 10% of calcium chloride. This mixture is maintained at the temperature of 1270 Kelvin. Okay, the 20% of alumina is obtained from bauxite ore. The calcium chloride is helps to lower the melting point of the mixture. The mixture melting points lower maintain பண்ணிட்டு இருக்கோம். Okay, and then after the electrolysis process, the ionization is carried out. The ionization alumina is A2O3 gives aluminum 3 plus and O2 minus. So the reaction at cathode is the Al3 plus 3 electrons is consumed to form the aluminum, pure aluminum we get. This is the net reactions. The carbon blocks use ஆகுது இல்லையா, carbon blocks act as a anode. Since the carbon blocks act as a anode to form it get oxidized to form carbon monoxide and carbon dioxide. This is a net reaction and we get pure aluminum. Pure aluminum is formed at the cathode. It's settled down at the bottom. Okay, so this is the electrochemical extraction of aluminum, that is Mat.Hr.Sec. process. Okay, thanks for watching. Thank you.